Alright, let's get started with the design. So we're going to start with a new component, and before you start any design, just save the object, the actual file, so that you have it. So we will name this to the base, and we will take the top, and then we want a rectangle. Let's go, say, 80 millimeters long by 35 millimeters wide. That seems like a good number to start with. I can double check that number with existing Raspberry Pi real quick here, just to get an idea, and also to get some idea. So we're going to want to go a little wider. Just measured it. We're looking at, let's say, 70 wide by, well, the Pi itself is basically 90 millimeters, but to get usable length, we're going to say, let's go 110 millimeters on the length. So 1, 0. And then that's going to be the outside, the inside diameter. So we're going to hit the O button for offset. We're going to select this, and oops, and we're going to drag that out. And for a good solid case, you'll probably want, let's say, 5 millimeters of extra girth here. That way we have a place so we can recess the inside portion. If you're going to make this out of metal, it makes the machining a little easier, so you don't have thin wall issues. And that's the idea behind this. So now we're going to hit E for extrude. We're going to select the outside wall, and for this case it's needs to be, let's say, 25-ish millimeters. Let's say 30 millimeters tall. Just so we have some air clearance and some room for pins. Alright, so now that we have the walls done, we're going to go underneath, and we're going to click on Create Sketch. We're going to click on the bottom, move it to the center, just click a corner here, click that, click Finish, and Extrude. Select both of those, and we're going to go down, let's say, 2 millimeters. And since those join, now we have a nice beautiful box here. But since we know that this is going to get machined, we need to put some fillets in here so that it's planned for. So what a fillet is it takes the two corners and it rounds them. And we're going to use a 6 millimeter end mill, so we'll make these a 3 millimeter. That way it's nice and clean. And we will also do that to the outside, just for aesthetics at this point, really. And then click that and that, and 3 millimeters there, just so we have a nice aesthetic looking box. Alright, so the next step is orientate it, is deciding which way you want it. So we need to add holes. Well, actually, it depends. We can build the studs into this design, like I've done for Young's project for the motor scooter, or I can build with just holes for standoffs. And I think for our case here, I'm just gonna do standoff holes. So what we do is we make a new sketch, click the inside there, and then we're going to go find a point, and click 4 points, because there's 4 holes. And then we need to start doing some referencing. Whoops, not D, not R. So we're gonna go off of that wall. Based on the measurements of my pie here, I know I need at least 4 millimeters on this wall. So we will go 4.5 millimeters for a little bit of clearance. And then for the back, we need clearance for both the pie itself and for the SD card. So for the back itself, you need 2.5, and then I like to add an extra 2.5 for the SD card stick out. So we will call that a nice even 5. So we'll do 5 millimeters there. And then for the next hole, we're just going to go down the line. That is 48 millimeters across. So we'll take this, go to here. Don't let it go crooked like this, because then you won't have an accurate angle. You need it to be horizontal, vertical in this case. So 48 millimeters, and then this one will also be 5. So instead of typing in 5, what I can do is I can click this first 5, and now you see where it says D13. That's a referenced item. So if I were to change that to 20, it follows it. So let's just change that back to 5. And that's a good way to, if you have a lot of the same dimensioned part, there's also other methods you can use where you can set up dimensioning that's a little more advanced, where you just type in a name and it knows the dimensioning based on that. Alright, and then for this part here, that's also going to be referenced off of that one. Also, if I need to adjust the referencing any, I have a quick way of doing so if I need to change it. And since we need to measure that screw length, which is let's see here, that appears to be 58 millimeters. So we just take this, go to there, make sure you don't have any weird angles going on. 58. And then this one will reference this, but again, don't make sure it's not perpendicular to this. You got to make sure it's vertical. And that's also 48. And this distance is the same as this distance, since it's a rectangle. And now we have our 4 holes. Now you click Finish Sketch. Think a minute. Right now, Fusion is under maintenance. I'm doing it in offline mode, so sometimes it hiccups. So now we're going to select these 4 points, and where it's red, it's where it cuts. But we're going to go over here. We're going to click Tapped, and we are going to use an M2.5. I believe is for the standoff we want. So we want to click 2.5 millimeter. We'll select the, let's see here, 0.45 pitch. I mean, there's also 0.35 pitch, but now we need to select our depth. We only have 2 millimeters to play with, so 2. And another thing, if you're going to make this for 3D printing, so right now you have a visual tab. It'll look like that. So if I click Finish, it's still a hole, so you still get the diameter of the minor diameter, so that you know what hole to drill. However, if you're going to 3D print this part, you can click on Modeled, and now it actually has modeled threads in there. So what you would do is you would 3D print it, and you could actually just screw your fastener right into that part right there. with no tapping needed. But we don't want to do that because it makes actual manufacturing a pain. And to be honest, if you're 3D printing, you can still just run a tap through it. So we click that, get rid of that. So now we have our 4 holes there. And now we're going to go to McMaster Car here and find some standoffs. So we click Insert, and it looks like because it's offline right now, McMaster Car's not showing up, which is a bummer. Let's see if I can. Let's see. Yeah, it looks like. So we won't worry about that for now. Alright, so the next part we need to make is the lid. So what we will do is now we'll make a new component. So what you do is you click the little toggle button here. So now you're in the full structure. And now you click Create New Component. And you're going to click the top of that. And now we're going to type in lid as a name. Click OK. And now you have a lid, except it went over there for some reason, so we will do that. So what we gotta do now is just move that up here. Alright, we'll just redo that one. For some reason it didn't. Alright. So we'll just make a new component, call it lid. There we go. Now it's properly associated. And you'll notice that this part grayed out. So when you have multiple parts in your assembly, or components rather, you have, when it's selected like this, where your radial is on the main tree, everything's visible unless you isolate. So as soon as I click on lid, it becomes transparent. And we're going to use that. So I'm going to create my sketch. I'm going to build it right on top of this, because what I'm going to do is I'm going to click up the P button for project. And I'm going to project that entire upper surface and then click OK. Now I can hide that lid, or that base rather, so I can focus on the lid. So I know my outer size is going to be the same as that other part. However, the inner size I need to make slightly smaller for clearances. So this is where you need to have a design constraint concept where you need to understand clearances. And if you're 3D printing the part, you need more clearance generally than if it's a machined part. But for this case, since I'm going to use screw fasteners to hold it together, it's not going to be an issue. So for this one, we're going to make it so that you could 3D print it. So I'm going to go with a 1mm gap here. So you have 1mm of play all around it, so that gives a little bit of looseness. And then we are going to extrude. And don't forget that little part there. And we're going to go 2mm. Okay. Now what I want to do is I want to go to the bottom. I'm going to make another extrusion. So I want to P for project. I'm just going to project that surface because it makes it easier. I'm going to do an offset of the inside now to half of that distance. So actually I need to find what that distance is now. We click that, we click that's fine, we're just using it as a reference. So now we're doing offset off of here, so we know that it needs to move 3mm. But since we are going the other direction, we gotta click a minus there. And there you go. Now you have a 3mm offset. So what we're gonna do on that is we're gonna remember our offset rules. So now I want to reduce that by 1mm for clearance. So I'm making that a 2mm hole. And then I'm going to click extrude and bring that down minus, actually no, we're going that way, so we don't have to do minus. So I want that to be probably 5 millimeters. That looks like it'd be a nice. So that gives you a little lip so that you have some casing on your case, so it lines up and you have some good seal. And once we get done with this lid part, we'll be doing a similar feature on the interior of the case as well. So now that portion's done, now we can click the top here, and we're just going to click project again, and then we can click OK and then OK. So we have I just did that so I had a place to click the surface. So we're going to go up 2 millimeters on that, and then because we're not animals, we're going to put some chamfers on this, just again style. And 1 millimeter looks pretty nice there, so we're going to stick with that. We're going to put a 1 millimeter on the bottom here as well for the same purpose, and that'll just help slide it into place. And we'll come back to the lid later, but for now, you see how the little recess on that, we want to turn that off. We want to turn this on. Make sure you click the little radio so that you're in that workspace, because down here you'll have a design tree that you can go through. And then we're going to click this create sketch, click up here, then we're going to click offset, click that, and we need to go -3 for that, and then extrude. And since we're going down, it's going to be -5.5. And see how operation switched from join or new to cut? That's what you want. You want it to cut. So now we have a nice little ridge there. And now we're going to put a chamfer on this inner edge. And this one. And 1 just seems to be a little too much for that, just because we're getting thinner walls now. So we will go with 0.5. And most likely this will be done by hand with a file anyway, so it's mostly there just to break your edges so that you don't have sharp edges that you're contending with. And there we go. And while we could fillet this base here, it'll be much more difficult to do with ball end mill and having to multiple work changes. So doing this, I can make this entire inside portion, including the outside contour, with only 3 tool changes. You have a spot, so we'll get to that in a moment though, but keep that in mind when you're designing parts. You want to design the part in a way that it is easy to manufacture, as well as be functional and be aesthetic. So now we got the lid on. You can click here. That looks pretty sweet. And we can go to display settings. We can go to we can go shader with hidden edges, so you can actually see the edges. Actually, you see every feature made in it. Or we can go to wireframe and with hidden edges, and kind of the same thing without the shading. So everything looks like it fits well. There's clearance, and that's what we want. And you'll see how those 2 surfaces don't touch. We want that. We don't want touching surfaces. That's just bad, because then things aren't working right. Whoops, we don't want shade. That just takes up way too much processing. We want shaded visible edges only. So if you do it the other way, you don't see the edges, and we want the edges, or else you don't know what's going on. Alright, so now we're going to do something a little different. We're going to rotate this, we're going to select the lid, we're going to click sketch, we're going to add our 4 points, but what we're going to do now is hit escape so we're not making any more points. We're going to click this little eyeball here, we're going to turn that off, and then we're going to hit P, we're going to project that, and we're going to project that, and then click OK, and then we're going to turn this little eyeball back on. So now you can see all of the underneath construction contours, because we need to add 4 screws to this. So what we're going to do is, since this will be where we want the screws in the corner here, around that radius, we're just going to drag those to those points. And oops, scrolled too fast. Alright, good. Now we're going to click Finish Sketch. And when the part that you're making is black, that means it's fully constrained. If it's blue, it's not constrained, and if it's purple, it's a projected feature, and if it's a dashed line, it's a construction feature, which doesn't get used for certain processes. So we've got both of these selected and visible, and that'll be important here, because what we're going to do is we're going to click hole like we did before. We're going to click that, this, and this. Whoops. There you go. And we're going to do this all in one step instead of having to make holes in both the lid and the base individually. This is going to be a counterbore hole, because aesthetic. We're going to make this a let's do it how big. Nope, 4 millimeters too big. So we'll go 3 millimeter and see what we can get here. Let's see here. That's weird. Four millimeters should work. I'll figure this part out. Actually, let's just cancel that, and then we'll start it again. Sometimes it gets a little glitchy, and I don't know why. Yeah, see, now it's working. We want 4, and we know that it's gonna penetrate the ledge a little. That's not an issue, because you'll see what's gonna happen here. It's a counterbore hole for M4. That size doesn't seem right though, but I know off of experience 6 millimeters is how wide that should be. So, and we want this to be let's go 3 millimeters deep, and then our hole will go down, let's say, yeah, 10 millimeters would be fine, but we are going to have a offset thread, and the offset will be 5 millimeters. So what that means is that the thread doesn't start until 5 millimeters down, and then the total will still be 10. So let's go another, let's make that 15 millimeters thick or down. And then we need to select the other 3 holes. And I know that it's going to rip out the corners here. That's okay. It's fine. If I wanted a slightly smaller screw, let's do that. Let's do 3 millimeter then. And that should be a 5 millimeter hole. And we can keep everything else the same. Click OK. And then we will select the main base. So now you have a fastened plate. So on the lid, you'll see how it goes down here slightly. That's okay. What we'll do is, actually, there's something that isn't okay. I need to fix that. Stupid pop-ups. Go back to the lid here. So sometimes you gotta play with things a little bit. I want the threading to be offset to 10 millimeters, not 5. And then we got 15 total. There we go. Now you see that you got threads down there. So another way you can do is just ignore the offset and just click full and do the offset yourself, which is what I will do, because on the lid itself you're not going to have any threads. So what you'll do is you'll just drill this up for a clearance hole. So at 3 millimeters you'll just drill a 3 millimeter hole instead. But to be honest, when you do the counter bore operation, that also creates a clearance hole, so it'll make it for you. So that part's not an issue. And then you've got your fully tapped holes. What you will do though is, in the order of operations, is you will drill these 4 holes first. Actually, you'll drill those ones too. Then before you do any other machining steps, you will actually tap all these holes so you don't have that non-continuous portion here not being tapped. And then when you do your machine operations, it'll cut it and it won't care. If you tap after the fact, you have to have a very sturdy, very rigid tap holder, and if you don't, it will go crooked and you can break your tap off, and you don't want that because then you scrap the part. So that's the basic part. That's how you'd make a simple Raspberry Pi case and lid. What we will add now is, on the lid side of things, you need some vent holes. So what we will do is, I'm going to pretend we're going to put a 40 millimeter fan on here. So we will take the lid here. I want a circle. We're going to make that, let's see here, I got a 40 millimeter fan here. I'll just measure one of these so I can save the time. That circle needs to be 37 millimeters. And then we will hit escape, hit the X button for a construction line. Where you see where that triangle is there, we click there because that's the center line. And then 180 degrees to the other center line. And now you can click X again. So this is a center line construction line. What we can do now is just drop that right on there, and now it's just gonna ride the center line. So our case faces this direction, so this side's gonna have your IO on it. So that means we want to make the fan hole over this way so that it's over the actual processor portion. So let's make that, say, 25 millimeters. That doesn't look like enough space, so we'll say 35 millimeters. There we go. That'll stick the fan right over the processor, the RAM, and all that other good stuff. But we're not done yet. Now we need to hit escape, go up to create, click on rectangle and center rectangle, and now we want to look at some spacing. So since it's a 40 millimeter fan, it obviously has 40 millimeter sides. So that's 40 by 40. And I do that just for layout purposes. So what I'm going to do is I'm going to select these four long edges. So now they're blue, they're selected. I'm going to hit X and deselect them, and now they're dashed lines, so they are construction lines. They're unlike this black circle here. That circle is a actual dimensioned line that will be used for machines. So you can select that circle. You can't select that box. And that's what we want, because now we need to put the screw holes for the what's the word for the fan in here. And I know these fans, because I have one in my hand, I have a pair of calipers, are a 3 millimeter hole. So I need to put a 3 millimeter screw in them. So I need to find my point tool, and they're going to be on these diagonals, and then we just need to measure, and I believe it is 37 between centers. 32 actually. So 32 between centers. So what we will do is take my dimensioning tool and click there and there and make that 32. Make that 32. Make this 32. And then that 32. Oops, not 232, just 32. And now they're all perfectly squared up on that line. That's good. So what we will do there is just keep that there for now, and then hit escape. And then we're going to do a few different things on this sketch, so there's going to be a little bit more going on here. I don't want just to have a big hole here for the fan, because fans don't get along. So we are going to add some lines. Since I got this center line here, we're going to start with that one. Now you see how that little section there turned black? Because that's now an actual line. So then we're going to use the offset tool. Not click that one, I don't want that one. So what you do is a long click, and you can select that or the other line. And I want to make that one offset one line there. And we're going to do the same for the other way. And that one will be -1. Whoops, that's not what I wanted at all. It said -1. There we go. So now I have a 2 millimeter slot here. So now what I will do is I will use the pattern tool, rectangular pattern. We're selecting that object and that object, and we're going to go both directions, so symmetric. I want, let's say 5, but nope, that's not going to be enough, so 7. Maybe that's going to be enough, we'll find. And then let's see here, distance, let's try 16. Sixteen's too, or let's do 9. There we go. That's what I want. Alright, so now I have this series of lines. So what I'm going to do now is click extrude. And working from my center, so that one stays, that one goes, that goes, that goes, that goes, that goes. And then we just do that. Click the bottom. Now we have a grid. But you notice my sketch disappeared. So what we can do is we can open up this, open up the sketches, turn the eyeball back on, and now we can click on hole, click on our 4 holes we made there before, and these will be just simple tapped holes. And there's 3mm. I got that set already. That looks good. And now we're going to come in on the bottom side. I'm going to click this because I'm going to do something a little different here. I'm going to project this square. And then I'm going to click OK. I'm going to select that, and I want to extrude it another millimeter. And then we need to go in here and make a fillet, so F for fillet. And then 3. And then click OK. And what we just did is made a small recess so that the fan can fit positively in it. That said, I should probably, let's see here. That's 40 across. These fans in reality aren't a true 40, so they're slightly under, but just for sakes of tolerances to keep consistent, we're going to add a millimeter of space around that. So what we'll do is we will go back to the sketch. Don't need that one anymore. Edit the sketch. And we'll just simply hit offset. Click that. Click that. That and this. Go -1. Finish sketch. And then we need to re-extrude it because we need to deselect that part. And then we gotta fix our fillets, which will be just selecting these again. I'm gonna make that 3. We can turn that sketch off now. And there you go, there's a nice lid. So what I would generally do for a Raspberry Pi in a box like this is I would make a custom PC board for the header. That way I can provide power to it, and then also I would build out a small connector so you can hook up the let's see, where's the base? So since this is the side that I had to have all the connectors, I'd build a little bridge so that the connector can actually go out the side here on a bulkhead fitting. And then for the Ethernet port and for the 4 USB ports. And then for power, I would actually add a barrel connector that just feeds 5 volts from outside, and it'll actually feed into the header pins of the actual Raspberry Pi. But I think this is about it for one video. If you have any questions, just let me know, and I will talk to you next time.